The HVAC unit is structured into three main sections. The mixed air compartment, supply air compartment, and the condenser section. The mixed air compartment is the control center of the air conditioner. As the name suggests, fresh air and return air flows merge in the mixed air compartment. Many serviceable components are situated in the mixed air compartment, namely, the fresh air damper is located behind the weather protection hood. The damper wings open to allow ambient air to enter. The damper wings close to prevent the ingress of smoke gases when smoke or fire is detected in the ambient air. The fresh air filter is arranged on the downstream side of the damper. It catches the dust particles suspended in the ambient air before it mixes with the return air. The mixed air filter is arranged in front of the cooling coil. It ensures that dust particles are removed from the mix of return and fresh air before it reaches the cooling or evaporator coil. The return air temperature sensor is installed under the mixed air filter. It measures the temperature of the return air when it enters the HVAC unit. Controlled by the return air temperature, the unit works in ventilation, cooling or heating mode in order to maintain the specified target temperature inside the driver's cab. The electrical control and power plugs are situated under the fresh air filter. They connect the HVAC unit to the wiring system of the rail car. The main control switch is mounted next to the plugs. The HVAC unit stops working with the switch in off position. The three-phase power cable leading to the cab air conditioner is protected with an MCB situated in the control cabinet behind the driver's desk. This MCB is labeled CACCB. If the MCB trips, the air conditioner cannot operate in any mode of operation. But note that in this situation, the air conditioner will not signal any fault to the TIMS because all its systems and components are healthy. The 110-volt DC cable which supplies the HVAC control system is protected with another MCB located in the driver's cab control cabinet. This MCB is labeled CACCCB. If the circuit breaker trips, the air conditioner cannot operate in any mode of operation. In addition, it will no longer communicate with the TIMS and it will be reported as unavailable on the TIMS HVAC screen. The electrical control panel houses the microcontroller and its relay and protective devices. The microcontroller communicates with the train information system TIMS through an RS485 serial communication interface. The electrical power panel accommodates the contactors and circuit breakers required to operate and protect the electrical equipment of the air conditioner. The circuit breakers can be monitored through a window in the front cover of the power panel. The supply air compartment houses the components required for the thermal conditioning of the air, like the cooling coil, heater bank, and supply fan. This is the cold evaporator coil. When the unit operates in cooling mode, the cold evaporator coil will remove heat and moisture from the driver's cab. The thermal expansion valve attached to the cooling coil controls the flow of the refrigerant into the coil to ensure its optimum performance. The heater bank is installed on the downstream side of the cooling coil. It is energized during operation in heating mode. It adds heat to the air in order to increase the temperature in the driver's cab during the winter time. The overheat protectors are attached to the heater arrangement. They will disconnect the heaters in case the temperature reaches an unsafe level. The supply fan draws the air from the mixed air compartment through the cooling coil and heater bank before discharging it into the cab. A transformer situated next to the fan allows to run the fan at different speeds. For high-speed operation, the fan motor is directly supplied with 415 volts. For operation at low speed, the transformer supplies a reduced voltage to the fan motor. It is important to note that the supply fan does always operate when the air conditioner is switched on. It works in ventilation as well as cooling and heating modes. The fan motor is protected with a motor protection circuit breaker (SFB). If the supply fan is disabled, the air conditioner will shut down and no cooling, heating or fresh air will be provided. The condenser section accommodates the refrigeration system components other than the cooling coil in particular: the condenser coil, the condenser fan, and refrigerant compressor. This is the compressor. During operation in cooling mode, the compressor pumps the refrigerant through the system in order to transport heat from the cooling coil to the condenser coil. The compressor is protected with a three-phase motor protection circuit breaker (CMB). It will disconnect the compressor if the motor current exceeds the set limit. The condenser fan is energized when the air conditioner operates in cooling mode. The fan motor is protected with a motor protection circuit breaker (CFB). If the condenser fan stops to operate in cooling mode, the HVAC controller will shut down the refrigeration circuit and no cooling will be available. The condenser fan draws ambient air through openings in the top and front sides of the HVAC enclosure. When the air passes through the coil, it picks up heat, which is then expelled to the outside air through the fan grill. These are the low and high pressure switches. The contacts of these switches are connected to the HVAC controller and cause the system to shut down when the reference pressure falls below or rises above the specified limits. The refrigerant sight glass allows a visual check of the refrigerant flow and condition. The sight glass can be viewed from the outside of the air conditioner through an inspection hole provided in the wall of the condenser section of the HVAC unit.